we are going to consider two large planes parallel with each other. This is two large planes. Given the charges of the equal magnitude and opposite sign, so in this case we consider the positive charge is given upper plate. So we consider the thickness of the planes. And the lower plate is a negative charge given. So in the charge densities, we use the charge densities. Surface charge density is a positive sigma and a negative sigma. And the sigma is positive values. And I would like to find the electric field. So we could consider electric field above the upper plate, electric field between the two plates, and the electric field below the lower plate. So first of all, we'd like to consider these two electric fields. Then we consider applied Gauss laws. So first of all, we'd like to consider the cylindrical surface. And the electric field is always perpendicular. We're not sure it's going up or down, but from the maybe up or down. But at least it should be the perpendicular to the plate. Then we'd like to consider apply the Gauss laws. Gauss law said surface integrals of the electric field is equal to 1 over epsilon naught and the volume integral of the charge densities. So in this case, we should consider the right-hand side charge inside of the cylinders. So inside of the cylinders, positive charge exists here and negative charge. But sum of the charge, this is positive and negative. Sum of charge should be 0 because the positive charge exactly cancel out the negative charge. So right hand side becomes 0. And the left hand side, if you consider the electric fields up and ds is upward parallel, E and the ds it's upward, then this becomes 2E A is the areas over the top and the bottoms. This is the area of A, this is area of A. So from these equations, we discovered electric field becomes 0. So outside of the plate to infinite plate, electric field becomes 0. This is the first step. Electric field outside of the plate. The plate. It becomes 0 electric field. For the second step, we consider the two infinite plate. And we'd like to find out the locations of the charges. So we consider cylinders, Gaussian surface of. So one of the bottom is inside of the upper plate, and the top is outside of the plate, and the electric field is 0, is outside. And of course, inside of the plate is a conducting plate, is electric field 0. Because if the electric field exists, charge is easily moved under the electric forces until the electric field becomes 0. So electric field inside of the conducting materials, electric field 0. So in this case, is electric field always 0 inside of this cylinder. We apply the Gauss law. So integrals E ds equal 1 over epsilon naught rho dv. So in this case, the electric field is 0. So left hand side becomes 0. So from these equations, charge, this is total charge inside of the cylinders. Q0 equal Q. So there is no charge in the upper plate. Charge on the upper side of the upper plane. So from this result, we discovered charge is located lower part of the plate, positive charge. Also, we could apply the same thing to discover the negative charge is located upper side of the lower plate. Okay, and the third step, we'd like to discover the electric field between the two plates. So we consider two plates, and the positive charge is placed lower side of the upper plate, lower surface, and the negative charge is placed upper surface of the lower plate. Then we'd like to consider Gaussian surface, the shape of the cylinders. Now, bottom is between the two plates. And as I explained, electric field is 0. Our upper regions of the upper plate, we have an electric field between the two plates. We assume this is directed downward. And then ds is also ds here. And the electric areas of these bottoms, surface area is given A. Then we apply the Gauss law on this Gaussian surface. E dot ds equal 1 over epsilon naught rho dv. In the left hand side, just we consider the contribution from the bottoms. So we just only consider these regions, okay, bottoms. Because of the surface integrals of the upper plate, this becomes 0. And also side is going to become 0. So we just only have a contribution from the bottoms. So E times A. And the density 1 over epsilon naught, charge in the plate. So charge comes from this part. So charge in this region is given by sigma, is surface charge density times area. So it becomes sigma A. From this equation, A appears in the both sides. It should be cancelled out. So E is given by sigma over epsilon naught. Okay, so this is the answer to these questions. Okay, this is the end of this practice.